Hi, my name is Charly Bisson,
And Amiris Campanella.
and for our YSP 2025 project, we examined the molecular complexity of amino acids with Drs. Celia Blanco and Ricardo Cabrera.
So, first of all, when we think about the huge diversity of molecules, questions may arise. How complex are the molecules? And could we even measure complexity? So, on this quickie project, we focus on different groups of amino acids. So, the first being detected in meteorites, the proteinogenic ones, they are the 20 essential amino acids in life, and the non-proteinogenic ones, they are the ones made by life. Our hypothesis was that they might be different levels of complexity on the datasets related or not in the biological process. So going to least complex that we expect to be the meteorite datasets to the most complex one that we expect to be the no-proteinogenic datasets. Our goal was to not only measure but to compare the molecular complexity among these groups.
But that begs the question of what molecular complexity even is, because it's a multifaceted concept that doesn't have one universally accepted definition. There are several different metrics, and there are two main categories that metrics fall under. The first is chemical graph theory, which treats a molecule as a graph, focusing on the connectivity and topology between the atoms and bonds in a molecule. And the second is chemical information theory, that focuses more on molecular features such as chirality, number of heteroatoms, and many, many more, to determine the molecule's ability to store information. And the different metrics utilize these different features in different ways, resulting in vast differences between metrics. This is a Pearson graph from last year's YSP that shows the different correlations between metrics for the same data set. You can get a lot of different values for the same molecule from these different metrics, showing their different ways of interpreting complexity.
So to understand the huge diversity of our datasets, we followed the methodology. The first was literature review, and then we moved to the practice. So we select the metric we were going to use, and then we understand better about the parameters and how it affects the final results. We do that on Google Spreadsheets. And then we implemented the calculations in Python using the Google Colab along with cheminformatics tools to not only measure but to compare the results.
And what we ended up with was graphical analysis between these three data sets of meteorites, proteinogenic amino acids, and non-proteinogenic amino acids that use specifically normalized complexity scores where the all of the metrics were integrated into one larger score that was normalized across the entire data set.
So as a first result, we have here the comparative graph with non-proteinogenic with proteinogenic amino acids. And we can see that perhaps our hypothesis was correctly because we can see that in the x-axis, we order by complexity and the non-proteinogenic ones is shown as the most complex ones. When we compare the proteinogenic with the meteoritic, we can see that they are very similar. But when we compare the non-proteinogenic with the meteoritic, we can see that again, perhaps our hypothesis was correctly because the meteoritic was shown to be with lower complexity and the non-proteinogenic with higher complexity.
Another way to visualize this exact same data is in a group data visualization with this violin plot, where you can see that the shape for meteoritic and proteinogenic amino acids is very similar with a similar distribution. However, non-proteinogenic amino acids not only have a larger range, but also a greater average, as you can see with the dashed line through the middle.
And after all the results, we can ask ourselves if there is a best metric for the molecular complexity calculations, and perhaps not, because each of them focuses on different aspects of the molecule. So together they can highlight that complexity is a multidimensional property.
But a comparison of abiotic and biotic molecules is yielding results in its initial stages, as we've seen with our comparison to our initial hypothesis and the data we ended up with.
And we can see also that cheminformatics can give us tools to explore more this field. And as a possible future applications, we can use this approach for life detection. It's really exciting. So thank you for listening, and I hope you enjoyed.
Thank you.